Hi friends, welcome to my channel. Let's have a look at today's daily challenge problem. Problem 1254. Number of closed islands. In this video, we're going to explain two methods. One is based on traversal, and the other is based on union find, also known as disjoint set abstract data type. First, I'll read through the problem statement. Then we explain our plan, and finally we explain the codes line by line. So first, the problem statement. We are given a 2D grid consisting of zeros and ones. So 0 means land and 1 means water. An island is a maximal 4-directionally connected group of zeros. And a closed island is an island totally surrounded by ones. So here we are going to return the number of closed islands. There are 3 examples. Let's look at the first two because this there are some pictures. In the first one, so this one is a valid closed island, and this one also. So we have 2. And in the second example, so we have only 1. So this 0 in the middle. All the other zeros actually are in the boundary. So in the third example, so we have here is a 1, right? It's a circle, and in between the middle 0 is another 1. So we have 2. The constraints for this problem are the following. First, the number of rows and columns of the grid is bounded below by 1 and bounded above by 100. And the elements in the grid is either 0 or 1, in other words, binary. So here 0 and 1 are integers. So with that said, we are ready to explain our plan. So here in this problem, this a little bit different than the typical problem of finding islands, because here we want the island to be closed. So here a closed island is an island totally surrounded by 1. So actually we need to write the above logic to the code. So the answer actually is simple. So if we want to use traversal, right, so we can use a check flag. So this is 1. And if we would like to use union find, we can use some special route. So again, let's emphasize that this problem is essentially finding connected components. Therefore, we're going to explain the 2 typical solutions, that is traversal based and union find based. With that said, let's look at coding. For the first solution, I'm going to write traversal based. So with a check. This is actually very routine. First, I'm going to get some information. Let's see. Preparation maybe. So let's get the number of rows and number of columns. Let's see. Grid 0. Length of grid 0. So this is number of rows and number of columns. And then we're going to write a hyper function or utility function. So here I'm going to write a single source traversal. So here let's define traversal. Let's accept a coordinate. And then I'm going to use a flag variable, originally true, right? This variable basically tells if the corresponding island, including this cell, is closed or not. So here also we initialize a set to aid our traversal. And then we're going to initialize a container. Let's see, this is the source, right? Next is basically the standard while loop. So while container. So we are going to first get the number, the row and column coordinates. That is container pop. So here we are popping from the tail. Also, we are going to use append from the tail. So this behavior is a stack. In other words, this format will correspond to a depth first based solution. If we pop from the left side and append from the right side, it's a queue behavior. The function will correspond to a breadth first search based traversal. But if you want to use breadth first based traversal, it's better to convert this container to be a deck, right? So that we can use pop left. So with that comment said, let's continue this depth first search based utility function. Here, first let's add this coordinates to the visited site, and then we are going to do a check if let's see, r in this set 0 or m-1, or c in this set 0 m-1. So this means r and c is in the boundary, right? In this case, so we're going to set the valid to be false, right? And then actually we implicitly assume that we are doing the traversal from a grid or cell with value 0, right? Now let's check the neighbors for xy in r-1c, r+1c, rc-1, rc+1, right? And then we are going to check if xy is inbound and corresponding to a 0 value and not visited, right? That is 0 less than or equal to x less than m, and 0 less than or equal to y less than n. And so the grid xy is 0, and also we want xy not in visited. If this is the case, so we're going to append the coordinates xy to the queue. Then after this while loop, what we are going to return is a tuple. The tuple, the first component is valid, this is the flag, and the other is the visited set. So with that done, so we are ready to do the counting, right? So let's initialize a count variable. So this count variable is used to count the number of closed island. And then let's make a universal set to aid our traversal. Basically, we don't want to repeat, right? And then we're going to iterate for I in range m, for j in range m, right? Then we're going to check if grid ij equals 0, and so we want to know ij not visited, right? Not visited yet, not in visited. Then we're going to do the traversal valid s. So the traverse ij, right? And then basically, if the island is closed, we're going to increment the count variable by 1. Otherwise, we do not increment. So no matter what, either closed or not closed, so we visited this cell. So we are going to update the visited set by the cluster s. Then we are going to do the return. So this small piece of code forms a solution format to this problem. Before we continue, let's do a check. Yeah, it passes a special example. Now let's look at the generic case. Yeah, it passes all the generic cases. So this is the first solution format we're going to present here. It corresponds to traversal-based solution. Now let me copy these signatures, and then I'll explain a solution based on, let's see, V1, UnionFind. So for UnionFind, we also need to deal with if island is closed. So for this, I'm going to use a special route. So typically for UnionFind, there are two options. So we can implement a UnionFind class outside this solution class, or we can just directly implement the union and find method inside this solution class. Here I'm going to choose the latter because once the grid is given, so we know the size of root and rex. So with that said, let's write the second solution. Here first, step 1. So I'm going to write the union find utilities. So first I get let's copy it here, the number of rows and number of columns. And then I'm going to have a root. So here we're going to use this ij and ij for I in range m, for j in range n. And then I copy this line, and then I'm going to make it a rack. So originally each cell has rack 1, right? So this is the general case. Also, I would like to treat the special root. So here mn, I'm going to set it to be mn. Then rack mm. So I'm going to choose a large number. So let's say m times n plus 1, as we like. So here, this two line is to treat the closedness, right? If a cell is with 0 value in the boundary, so we're going to set its root to be mn, right? Because we're going to use union by rank, so we set a large rank for this root initially. So next, we're going to do the find and method and union method. So also we want to do the union method. So here we are going to write formally. The reason is that here k will represent a tuple, similarly k1 and k2, right? First, I'm going to write result to be the root of k, right? Then basically a while loop, while result does not equal to root result. Then basically what we want to do is to set result to be root of result. And then we retrieve upwards, right? So after we exit while loop, so we're going to have result and root result are the same thing. And then we just return the result. So in order to accelerate the process, so we're going to apply path compression, right? So we apply to root in both sides here. So basically, we set the result, the root, to be the root of its root. So this way, we make a shorter path from the result to root. So this is path compression. This is one way of writing path compression. So if in the chain you can set all the nodes in the chain to the root, that's also a good thing to do. So this is the find method. Now let's look at the union method. For the union method, so because we have already implemented the find method, let's first find the root R1 and R2. Let's find K1, find K2, right? Then if R1 equals R2, then we do nothing. Otherwise, we're going to check the rank. If rank R1 is no less than rank of R2. In this case, so we're going to set the root of R2 to be R1. And then we're going to increment the rank of R1 by that of R2, right? So let's change this to be plus equal. So otherwise, actually, we do the same thing, but in the other direction. So this else. So we are going to set the root of R1 to be R2. And then we are going to increment the rank of R2 by that of R1. That's it for the union operation, right? So now we finished the step 1. Next, we are going to write our step 2. So the problem logic. So this is actually very similar to the solution here. So I would mention that it's better to look at to keep this block in mind and compare with the union find method. So now let's do this. So we're going to iterate for I in range m, for j in range n, right? Then first we're going to check if grid ij equals 0, right? So if it's 1, so we just ignore that or continue. If it's 0, so we do two things, parallel here with here. So we do check, right? So if R is like this, so it means R and so here not R, so it's IG, right? So we're going to do the union. So we will set the root of this ij to be mn, right? Mn ij, and then we continue. Otherwise, so I will be greater than 0 and less than m minus 1, and j will be greater than 0 and less than n minus 1. Then we're going to check if grade, let's see, I minus 1j is 0, right? If so, we are going to do the union. So we're going to write I minus 1j and ij, right? So notice that we put the this one, because this one is first retrieved in this for double for loop, right? So we put it front. No, actually, this union function is not symmetric, right? Due to this one here is greater than or equal. Here is equal. So, but the order here does not matter. But let's do this to keep it organized. And then grade I plus 1j, right? If this is also 0, then we're going to do union. So because I plus 1j is come after, so I'm going to do this. I plus 1j, right? Then I'm going to check if grade I, fix I, and check j minus 1. If this is 0, then I'm going to do union. So I, j minus 1, and union with I minus j. Again, this in the front, ij is in the second. Similarly, I'm going to check I and j plus 1. If this is also 0, then we do union, right? So I, j, and I, j plus 1. So with that done, we finish the problem logic. So next, we do counting, right? Similar thing, counting. So first, I'm going to get the number of unique roots, that is the number of clusters. And then we want to exclude the closed island. Notice that in our treatment, all the non-closed island have root, this mn, right? We regarded them as 1. So first we are going to get clusters representations. So we're going to use a set. And what we're going to do is to do find, right? ij. So for I in range m, for j in range m. So we check the 0 cells for ij equals 0, right? So these are the clusters. So we maybe use a quotation mark because all the closed islands are combined with one root. But anyway, so we're going to return the length of this set minus this set, mn, because this is the special root. So with that said, we are ready to do the check. Let's see. Clusters, find take one position. Let's see. Oh, here, yeah. Let's write like this. This is the sort of formality, right? This is represented as the key. So yeah, it passes a special example. Now let's look at the generic case. Yeah, it passes all the generic cases. So this finished the second solution format. So here in this video, we present two solutions to this sort of routine problem. So one is based on traversal, and the other is based on union find. The reason we can use the two methods here is due to the fact that this problem is essentially finding connected components, right? And also, if we dive deeper into the two solutions, here the if block and the for block, and here the if block and else block, so they are in parallel, right? So essentially they are the same solution, I would say. With that said, I guess that's about it for this video. It's all sort of long. And if you found the explanation here useful, you're welcome to follow up my video on YouTube channel. Thank you.